In the following few videos, I will just try to present some trigonometry that will give you a basic understanding of the trigonometry of the special angles. So this is not really a lecture in trigonometry, rather than just a cram session in what you need to know before the midterm. Okay, so first we're going to start with the trigonometry in a right triangle. So assume that we have a right angle triangle. Okay, and then we talk about the angle theta right here. Okay, so let's say that this is going to be the side opposite of theta, which can be called A, or opposite of theta. Then we have a side that's adjacent to theta, that's called B, and always in the right angle triangle, the side opposite of the right angle is the hypotenuse, so H. Okay, so we define the following 6 trigonometric functions. That sine of theta, it's nothing else but the ratio between the opposite side of theta and the hypotenuse, so that's A over H. Okay, somebody is used to identifying this as the opposite side over the hypotenuse. Okay, cosine of theta is the ratio between the adjacent side and the hypotenuse, or adjacent over hypotenuse. And tangent of theta is equal to the opposite side over the adjacent. Of course, with respect to this angle, right? I say tangent of theta. If I take this angle here, then the functions of this angle obviously are going to be different. So tangent of theta is the opposite A over the hypotenuse side B, or if you want, opposite over adjacent. Okay. To these three trigonometric functions, we defined their reciprocals. Okay, so the reciprocal of sine of theta is cosecant of theta. So the reciprocal of A over H would be H over A, which is the hypotenuse over the opposite. The reciprocal of cosine of theta is called secant of theta. That's equal to the hypotenuse over the adjacent. And at the end, the reciprocal of tangent of theta is cotangent of theta, and that's the adjacent over the opposite. Okay, so now we want to know these sine, cosine, and tangent of these three very famous angles, and those angles are 30 degrees, 40 degrees, and 30 degrees, 45 degrees, and 60 degrees. Okay, so let's sketch the following two triangles. Okay, this triangle has sides 1, 1, and then if you're looking for the hypotenuse is going to be square root of 2. Okay, since these two sides are equal, these two angles are going to be equal. And if this is 90 degrees, 180 minus 90 is 90, divided by 2 is 45 degrees. So 45 degrees, or in radians, and from now on we're just going to work with radians, is pi over 4. So 45 degrees is pi over 4. Okay, based on this here, right away you can write how much is sine of pi over 4. Okay, so in this case it's opposite over hypotenuse, so 1 over square root of 2, or the way we write it, that's square root of 2 over 2 by rationalizing the denominator. Okay, cosine of pi over 4, that's adjacent over hypotenuse, again the same thing. So this is one way to remember this, that all sine of pi over 4 and cosine of pi over 4 is the same. Tangent of pi over 4 is opposite over adjacent, so 1 over 1, that's 1. Okay, and then you have the reciprocals. So I'm not going to write them here, because the reciprocal, if I ask you how much is cosecant of pi over 4, the moment you know sine pi over 4, then cosecant is just going to be reciprocal of 1 over square root of 2, and that's just square root of 2. So this is the first special triangle that you need to know that gives you the trigonometric values of 45 degrees. And the second one it's a right angle triangle with hypotenuse 2. The second longest side is square root of 3 and the shortest side is 1. So opposite of the shortest side is going to be the smallest angle, that's pi over 6 or 30 degrees. Opposite of the side with length square root of 3 is the angle pi over 3. Okay, so now I want to find pi over 3 is 60 degrees and pi over 6 is 30 degrees. So how much is sine of pi over 6? That's opposite over hypotenuse, 1/2. Cosine of pi over 6 is adjacent over hypotenuse, square root of 3 over 2. And sine of pi over 3 of 60 degrees, sine of pi over 3 is opposite over hypotenuse, square root of 3 over 2. And cosine of pi over 3, cosine of pi over 3 is equal to adjacent over hypotenuse, right? Once you know sine and cosine, right, of these angles, then you can do all the rest of the trigonometric functions right here. Now, what is the main question? The main question is how to use these angles in order to find, in order to evaluate these trigonometric functions at any multiple of these angles, pi over 4, pi over 6, and pi over 3. I will cover that in the next video. Now I want to show you, I want to share with you a way to remember this, although I'm not big fan of these tricks how to memorize things in mathematics, but since our test is in less than a week from now, maybe this will be helpful for some of you. Okay, so here how to remember the sine and cosine value. So this is sine of theta, and here I'm going to put cosine of theta, and here I'm going to put the angle theta. Okay, I'm gonna, for theta I'll have 0, pi over 6, that's 30 degrees, pi over 4, that's 45 degrees, pi over 3, that's 60 degrees, and finally pi over 2, which is 90 degrees, right? So this is 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay, so the trick how to remember the sine value of these angles here, and in the next video I will show you why these are so important, is the following one. First, write here just 0, 1, 2, 3, 4. Now take the square root of these numbers here, and then divide these square roots by 2. Now, of course, square root of 0 is 0. 0 over 2 is 0. Square root of 1 is 1, so I have 1/2. Square root of 2, you don't simplify it, stays square root of 2 over 2. Square root of 3 also you don't simplify it, stays square root of 3 over 2. And square root of 4 is 2, so 2 over 2 is 1. So that's how sine of 0 is 0, sine of pi over 6 is 1/2, sine of pi over 4 is square root of 2 over 2, sine of pi over 3 is square root of 3 over 2, sine of pi over 2 is 1. Okay, so maybe you want to write this down right away when the test is going to start. Write this down for all of you that are seeing this for the first time, so maybe it will help you. Now, how does that relate to cosine of theta? Well, cosine of 0, pi over 6, pi over 4, pi over 3, and pi over 2 are these values in the reverse order. So just copy them. First 1, then square root of 3 over 2. This is in the middle, so stays where it is, square root of 2 over 2. The next one is 1/2, and the last one is 0. So cosine of 90 degrees, cosine of pi over 2 is 0. In the next video, I will show you how, that's the difficult part, how using these angles, okay, these values, you will be able to find the rest of the trigonometric functions evaluated at any angles that are multiples, right, integer multiples of these angles right here.